Hi everyone, these are the notes for lesson 15, quadratic equations with irrational solutions. Our objectives today are I can use the radical and the plus minus symbols to represent solutions to quadratic equations, and I know why the plus minus symbol is used when solving quadratic equations by finding square roots. So let's start off by looking at the roots of squares. We have three squares, A, B, and C, whose vertices are all on a grid. Take a minute to find the area and the side length of each square and press play when you're ready to check. Alright, so for A, hopefully you saw that the area was 9 square units, and that one should have been pretty simple to find, and that each side length would be 3 units. When we look at B and C, we have tilted squares, and so you had to think of a different method rather than just counting the side length and then squaring it to find the area. So for B, you may have thought about finding one of the side lengths first by looking at these as right triangles and thinking about the Pythagorean theorem. So you knew that these sides were both 1, and so you know the Pythagorean theorem said a squared plus b squared equals c squared, where c is our hypotenuse, or the side length of the square that we're looking for in this case. So we'd have 1 squared plus 1 squared would be 2 equals c squared, and if we take the square root, we would get that c, that hypotenuse there, equals the square root of 2. And so my side length would be the square root of 2 units, and if I square that to find my area, I would get that the square root of 2 squared would equal 2 square units. Now you may have found a different method to find the area and the side length, and that's fine too. And for C, I have another tilted square. You may have decomposed this by looking at there being 1 square in the center. That was 4 square units, and then taking this piece and adding it here to make one rectangle with an area of 1, 2, 3 square units, and taking this one here, moving it here, and giving you one more area with 3 square units. So 3 plus 3 plus 4 would give you 10 square units for your area. And each of your side lengths then would have to be the square root of 10 units in length. Now notice that I left the side lengths for B and C in radical form. So I didn't approximate them or I gave an exact value. And using the square root notation, the square root of 2 or the square root of 10 is referring to the positive square root of that number, because that symbol generally in math refers to just the positive one, which makes sense, right, in this situation because we're talking about side lengths and we need those to be positive values. All right, in 15.2, we're going to look at how we can continue to write solutions using square roots, using that radical symbol, and why we'd like to do that. So we're going to solve each equation, and we're going to use the plus minus notation when appropriate. So when we talk about the plus minus notation, this is what we're talking about. It's like a plus sign and a minus sign right underneath it. And we're going to talk more about what that means. Okay, so if I'm looking at number 1, to solve this, I could add 13 to both sides, and I'll get that x squared equals 1. And if I take the square root of both sides, I know that then x is going to be equal to the square root of 1, which is just 1. Oops. Which is just 1. But remember, if we're taking the square root of it, it has to be either a positive 1 or a negative 1. So instead of writing x equals 1 and x equals negative 1, we can just write that a little more concisely by saying x equals plus or minus 1, meaning that x could equal positive 1 or x could equal negative 1. And so we use that plus minus symbol in front to denote that that solution can either be positive 1 or negative 1. All right, for number 2, we have x minus the quantity of the difference of x and 6 squared equals 0. And so here, if we were to take the square root of both sides, we can say that x minus 6 equals 0, and therefore x has to equal 6. Now we know based on the zero product property as well that in this case we only have one solution, and that is x equals 6, not positive or negative 6 in this case. All right, for 3, we have x squared plus 9 equals 0. Now, I can see right off the bat that there's going to be no solution. But if I do move that 9 to the right side, I have x squared equals negative 9, which I know is not possible. So I can't square any number that we know of currently to get a negative number. So we know we have no solution here for 3. All right, number 4. If I were to take the square root of both sides here, I get that x equals plus or minus the square root of 18. Now if I try to take the square root of 18, I'm going to get an irrational number, right? Because it's not a perfect square. And so to make sure we have an exact answer for this, we can leave it in radical form.
The important thing to do is make sure that you simplify. So hopefully you remember what we talked about with simplification. So we know that the square root of 18 does have a perfect square factor of 9. So we have positive or negative 9, root 9 times 2, which then simplifies to positive or negative 3 root 2. So don't forget to simplify your radicals.
Here, we would subtract 1. We'd have x squared equals 17. Again, if I take the square root, I'm going to get that x equals plus or minus the square root of 17. And again, that's my exact solution. 6, if I take the square root first here, I'd get that x plus 1 equals plus or minus the square root of 18. Now, if I want to take away 1 from both sides, typically how I would write that would be x equals negative 1 plus or minus the square root of 18. And what this is saying, what this solution means, or what this represents when you see it written this way, is that I have two possible solutions for x. X could equal negative 1 plus the square root of 18, or x could equal negative 1 minus the square root of 18. And those are my two different solutions.
So again, you need to remember that you still have to take that and put it in simplest form. So we already simplified square root of 18 to be 3 square root of 2. So one way that you could possibly write this is as negative 1 plus or minus 3 root 2. The important thing is that you put the 3 behind the plus or minus. It can't go in front of the plus or minus because we have that negative 1 there. Again, that would just be negative 1 plus 3 root 2 and negative 1 minus 3 root 2.
Okay, so this might be the first time that you're seeing this notation, and it might be a little bit different for you, but note that what it represents, right? Just what it looks like, a positive or a negative version. Now, when we look at our answers, our solutions here for 4 through 6, you might have noticed that we left those in radical form. So all 3 of these solutions are irrational numbers, whereas our solutions for 1 and 2, right, were rational. And so remember that a rational number is a fraction or a number that can be written as a fraction or its opposite. And irrational numbers are numbers that are not rational. And we'll talk more about that later, but examples would be the square root of 2, pi, square root of 10, square root of 17, some of these numbers that we're seeing here. When we have irrational solutions, the most concise way to write an exact solution is to write it how we did here for number 4, 5, and 6, because this is exact. The only other way to write it would be to find the approximate value for those square roots and then calculate from there. But again, that would only give us an approximate solution and not an exact solution. And so that's why we like to use those radicals and leave them in that form, because it gives us an exact answer. Okay. Just to note, sorry, before we move on, if we're looking at 6, right, notice that I wrote -1 plus or minus the square root of 18. That's one of the most concise ways to write it, and then we're said that that meant x equals -1 plus the square root of 18, or x equals -1 minus. You can also write it the opposite way, 2x equals plus or minus the square root of 18 minus 1 instead of, and then so then you've wrote it out both ways, x equals square root of 18 minus 1, or x equals the opposite of the square root of 18 minus 1. So you can write them that way too, but typically you'll see it written the first way, where you have the rational number first, followed by the plus or minus and your radical. All right, so let's look at finding irrational solutions by completing the square. Here we have an example of an equation being solved by graphing and by completing the square. So we can see it graphed here, we can see our solutions are right here, and we see that they are both decimals. And so we can guess that those might be approximations. They may not be exact when we see decimals like that. We don't know yet. But if we look at the equation and it was solved by completing the square, we see that the exact answer that they got was x equals -3 plus or minus the square root of 2. Now it says to verify. So we're going to verify that the square root of 2 is approximately 1.414. So if you take the square root of 2 on a calculator, that's what you'll get, plus some more decimals. And so if we were to figure out that approximation, we could say, well, -3 plus the square root of 2, so -3 plus 1.414 is going to give us about -1.586. And then if we subtracted -1 minus the square root of 2, so -3 minus 1.414, that's going to give us about -4.414. And so those would be our approximations. And we can see that those match the solutions on the graph. And so we know that -3 plus or minus the square root of 2 is our exact solution. And that the graph, and then here, these are our approximate solutions. So for each equation, you're going to find the exact solutions by completing the square, and then the approximate solutions by graphing, and then verify that the solutions found using the two methods are close. I'm going to do the first one with you before you move on to the rest, but if at any point you feel like you're ready to move on, you go ahead and try it on your own. Okay, so if I have 4, I'm going to say half of 4 is 2, and 2 squared is 4. So I need my constant here to be 4. And so I can get there by adding 3 to both sides. So I have x squared plus 4x plus 4 equals 3. And now I can rewrite that as square factors. So x plus 2 squared equals 3. I can take the square root of both sides, and I'd get that x plus 2 equals plus or minus the square root of 3. Subtract 2 from both sides. and I get that x equals -2 plus or minus the square root of 3. And remember, this is representing two solutions. It represents the solution where x equals -2 plus the square root of 3, and x equals -2 minus the square root of 3. Okay, if I go to Desmos and I graph this, I have x squared plus 4x plus 1. And I look at my zeros here, my solutions. I have -3.732. I'm just going to take a screenshot and add this to our notes. Okay, and so when we do this, we can see here that here's our approximate solutions, and then here was our exact solution. And if we want to verify that these two things match up, I can say that if I use a calculator, I can say that the square root of 3 is about, or approximately, 1.732. And if I do -2 plus 1.732, I'm going to get that that equals approximately -2679 or 268, which matches with this solution on our graph, and -2 minus 1.732, I get that that solution is approximately -3.732, which matches with this solution on our graph. So that's how we would verify that our exact solution that we leave using the radical symbol and in radical form matches our approximate solution if we were to solve by graphing. So we can see that they are the same thing. One is just exact and one is an approximation. Okay, why don't you take a minute to try number 2, and then you can check your answers. Okay, so if you went through number 2, if you should have gotten that 5 plus or minus the square root of 7 is your exact answer by completing the square, and that your approximate answers are x equals about 2.354 and x is about 7.646. And you should show that you were able to do that by completing the square and graphing, and then verify that those two things are the same. All right, do the same thing for 3 and 4. If you feel confident in working on this, go ahead and do them on your own. I'll do one more. I'll do number 3 and give you just the answers for number 4 to check so that you can practice on your own. All right, so if I'm going to complete the square, here at 5, half of 5 is 2.5, and 2.5 squared is 6.25. So I need to basically add 6 to both sides to get a perfect square. And then I can factor. So I'd have x plus, I'll just leave it as 5 halves, equals 6. Take the square root of both sides, and I get x plus 5/2 equals plus or minus the square root of 6. And now I'm going to subtract that 5/2 from both sides. So I get x equals negative 5/2 plus or minus the square root of 6. And when I graph this, so there's my exact, and then if I graph, I'm going to see my solutions, and x is approximately negative 4.949. Okay, and then I'm going to verify that these two things are the same. And so I'm going to look at the square root of 6 is about 2.449. And so if I do negative 2.5 plus 2.449, I'm going to get negative 0.051, which matches that solution. And if I do negative 2.5 minus 2.449, I'm going to get negative 4.949, which, matches my other solution. So I verified that my exact was done correctly. I found the right answer because it matches the approximations that I got by graphing. All right, you try and show the work for number 4 like you did with number 2. And I'm just going to give you the answer so that you can check to make sure that you understand. If you're not getting this, you should definitely reach out to your teacher to get help. But you should get that x is negative 4/3 plus or minus the square root of 2/9. And you can just leave it like that. And there's your exact. And your approximations are x is about negative 862, negative 1.805. And those would be your approximations, and you can verify that those things are the same. Don't be afraid of this one because it has fractions, and you're doing everything exactly the same way. Okay, so we know a benefit of graphing, right, is it's pretty quick, it's straightforward, it's easy to see. However, it does not give us exact solutions, and that's why we like being able to complete the square. It takes a little longer, it can be time consuming, but it gives us those exact values that we need when we need or are looking for precision. Okay, so when we're solving quadratic equations, it's important to remember that we already know that any positive number has 2 square roots. We know that one is positive and one is negative, because we know there are 2 numbers that can be squared to make that number. Note that the square root symbol can be used to express the positive square root of a number. So typically, conventionally, right, conventions dictate that when we see that square root symbol, we're talking about the positive square root of that number. And if we want to express the negative square root of a number, like 36, we can just put the negative sign in. And so that's where we get that plus or minus the square root. If a number is not a perfect square, for example 40, we can express it by just writing it like this, because that gives us exact, and those are irrational numbers. How we could write the solution, remember that we can still add or subtract something when we're using that plus minus sign, which is that more compact way that we're looking to go. So negative 4 plus or minus the square root of 11, and that we can find approximate values of that by calculating it out or by graphing and finding those zeros there. Okay, that's it for lesson 15.